So we are discussing about the Schrodinger equation here. Schrodinger was a person who gave us the ideology of the quantum numbers. So he assumed that the electron is traveling around the nucleus as a wave. So electron travels around the nucleus like a three-dimensional wave. The Schrodinger wave equation is provided as such. Psi, the wave function of this particular wave, is equal to dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square. You can see it is being expressing about the x, y, z Cartesian coordinates. That means I say the electron is moving. In which axis it is moving? X, y and z. So we assume this electron is present in a three-dimensional space. That's the reason we are introducing x, y and z with respect to x, with respect to y, with respect to z. Plus 8 pi square m by x square into e minus v into psi is equal to 0. So this whole equation accounts for the Schrodinger's equation here. Now psi corresponds to wave function of the electron. This could be positive, this could be negative based on the coordinates. I guess you remember that when we were discussing about the radial distribution curve, the very first curve was drawn between the psi and the r. We found that there was a negative coordinate also like this. Do you remember this?
Yes, ma'am.
To remove that only we just squared it and we said it is a probability density factor. So this psi could be positive as well as negative based on the coordinate. What is this E corresponds to? The E is the total energy of the electron that is revolving around the nucleus. What is this V then? The V is the kinetic energy of the electron. V corresponds to the energy of the electron into psi is equal to 0. Now this psi is given in terms of two parts. One is called radial part, another is called as angular part. Radial part and angular part. You can see this capital R in terms of R, radial part. And this is angular. You can see the theta and phi that is given. The radial part gives you about the energy and the size of the orbital. So you can very much relate it with respect to a principal quantum number. It gives you about the energy and size of the orbital. This A, which is your angular part, talks about the shape of the orbital. So you can very well assume it with respect, relate it with respect to azimuthal quantum number here. So whenever you see a Schrodinger equation, the Schrodinger equation will provide you two parts here. Part number 1, e power minus zr divided by n a naught. E power minus zr divided by n a naught, where r is the radial distance from the nucleus, a naught is the radius of the first Bohr's orbit, and n is the number of the shell. In which number is the shell available, that gives you the n value here. In other words, nothing but the principal quantum number here. Okay, and psi will also be having the next format, 1 by a naught power 3 by 2 plus L. 1 by 2 power 1 by a naught power 3 by 2 plus L. So just by looking at the Schrodinger equation, we will be able to identify what is the specific orbital that is provided here. Let us understand it with an example. Here psi is equal to 1 by root pi a naught power 3 by 2 into e power minus r by a naught. I told you any Schrodinger will have e power minus zr by n a naught. I also told you it will have 1 by a naught power 3 by 2 plus L. Correct? So let us look at the values here. They are asking you what orbital is that. Ma'am, I can see this n is not mentioned at all here. So n should be 1 obviously. Look at this value here. 1 by a naught power 3 by 2 is only given. That means there is nothing given here, which is nothing but 0. Is that right?
Yes, ma'am.
So L value corresponds to be 0 here. Now mention the orbital. N is 1, L is 0, so it is 1s.
Okay, ma'am.
Mridula, did you understand?
Yes, ma'am.
Oh.
Ma'am, can you go up once?
Hmm.
Like about thank you, ma'am.
Okay. Let's look at the next equation. Look at the e power part here. You can see some cos theta is provided, so definitely some angular function is available. It can't be a s orbital. That's my understanding. I am looking at this value. What is the n value here? 3.
3.
Now go for this part. 1 by 3 by 1 by a naught power 3 by 2 plus L. Ma'am, here also nothing is provided, ma'am. Wait. Look at your previous case. Here, you are provided directly to the next term e power minus r by a naught. But in the second equation, it proceeds. You can see it is having 6 minus r by a naught. Again, a naught is here. Again, r by a naught. Correct? Which is nothing but that corresponds to this 1 by a naught. 3 by 2 is here. Accepted. What about this value? For this value, I have to take the consideration of these two forms here. So the shortcut to identify is that whenever your r by a naught is provided without exponential, here also r by a naught is there, but here it is an exponential function, leave it out. Other than that, whichever is available alone, all alone, that means not with this kind of integer part, not like this part, just like that it is available. Take its coefficient. What is the coefficient? 1. So it corresponds to the L value. L is 1 year. Do you understand till this?
Yes, ma'am.
Yes. So let us compose it. N is 3. L is 1. What is the orbital then? 3p. Is that 3p? Tanuja, did
Yes,
you
ma'am.
understand?
Yes, ma'am.
Right. Look at this variant here. N is 3. Okay. What about the L value, ma'am? Here it is r square by a naught square. Isn't it r by a naught power 2? So can I assume the L value as 2 here?
Yes, ma'am.
So go for the orbital 3D it is. So in your JEE examination, they will just club giving you this radial distribution function, asking you to find the radial distribution curve or the nodes. 3D has how many radial nodes? How many radial nodes it has got?
2, ma'am.
How come?
Like n minus n minus 1,
Okay, go on. What is the n value?
3,
What is the L value?
2, ma'am.
Then what's your value?
As 0.
0. You need not even go and hit at the formula. There is no 1D or 2D and all. It starts with 3D only. Then how can we will have radial node? Understood, Ra?
Yes, ma'am.
Right. You can look over here. E power minus sigma by r 3, again some sigma. They said sigma is nothing but r by a naught. So let's re-establish. This is 3 a naught, correct? E power minus sigma by 3. Sigma is r by a naught. So I am just writing it here. Similarly here also I can write it r by a naught. R by a naught square. Am I right?
Yes, ma'am.
So as I mentioned you, go for your n value from here. N is 3. You should take the r by a naught value when it is not attached with any other values. Here it is attached with a value, here it is attached with a value. Correct? So that I cannot assume any of the value there. So it is L becomes 0. So it is 3s.
Ma'am, is there no case where
Hmm.
like L is not 0 but it's still attached?
Sorry, repeat.
Ma'am, is there no case where L is not 0 but it is attached?
No. Let's go for one of the question here. You have provided psi 2s is equal to, where a naught is the board's radius. If the radial node is 2s, in 2s is at r naught. They have provided for 2s, where is the radial node? At certain radius r naught. Find r naught in terms of a naught. Find r naught in terms of a naught. Okay. Now they mentioned this radial node. What do you mean by radial node? What is node actually? Where there is zero electron density. There is no electron density at all at that position. Correct?
Yes, ma'am.
That means my probability function itself becomes 0. What is psi square? Probability density factor. The place where you can find the maximum number of electrons. They are mentioning about radial node, where there is no electron density at all. So does that mean that psi square is becoming 0 at that place?
Yes, ma'am.
Yes. So I am taking this equation, I am just squaring it and I am equating it to 0. I am saying this whole equation becomes equal to 0. So you can see this exponential term is here, which also turns out to be 0. You can see this something is in multiplication symbol, that also turns out to be 0. Corrected?
Yes, ma'am.
And I'm not actually squaring them because they are anyhow turning out to be 0, so I'm just excluding them. So this whole term is also equal to 0. Since something is involved with negative signs here, I can't say it is also 0, isn't it? Here
Yes,
it is
ma'am.
2 minus r naught by a naught power 2 is equal to 0. In other words, I understand 2 minus r naught by a naught is equal to 0. So they are asking you to calculate this r naught value in terms of a naught. So you find out to be 2a naught.
Okay, ma'am.
Okay, so that was regarding your Schrodinger's equation. Now we'll continue with the redox reactions.